New images that combine data from NASA's Chandra X-ray Observatory and the James Webb Space Telescope, JWST, have just been released. The images feature 4 iconic astronomical objects, showcasing the capabilities of these observatories by combining light in the visible, infrared, and X-ray wavelengths. These include the NGC 346 star cluster located in the Small Magellanic Cloud, SMC, the NGC 1672 spiral galaxy, the Eagle Nebula, Messier 16, or M16, and the spiral galaxy Messier 74, aka the Phantom Galaxy. These objects were made famous by the venerable Hubble Space Telescope, which took pictures of them between 1995 and 2005. Since it commenced operations, the JWST has conducted follow-up observations that provided a sharper view of these objects that captured additional features. Hubble and the JWST even teamed up to provide a multi-wavelength view of the Phantom Galaxy last year. By adding Chandra's famed X-ray imaging capabilities to Webb sensitivity and infrared light, these latest images provide a new glimpse of these objects, revealing both faint and more energetic and powerful features. The JWST has provided us with the most detailed and breathtaking images of the universe to date. This is to the observatory's 6.5-meter, 21 feet 4 inches, primary mirror, made up of gold-plated beryllium plates, and its sensitive infrared instruments, capable of imaging objects in the near, mid, and far infrared, near, and far. Its revolutionary sunshield also keeps the observatory at cryogenic temperatures, ensuring it does not suffer from solar interference. Alas, there are some wavelengths the JWST can't visualize, which prevents it from capturing certain celestial phenomena. Remove all ads on Universe Today. Join our Patreon for as little as $3. Get the ad-free experience for life credit. NASA, ESA, STSCI, ESO, Optical, NASA, ESA, CSA, JPL, STSCI, IR, NASA, CXC, SAO, ESA, XMM Newton, X-ray, image processing, L. Frater, J Major, N Woke, and K Arkan. Chandra is one of NASA's 4 great observatories, which includes Hubble, the Spitzer Space Telescope, and the Compton Gamma Ray Observatory. It was deployed in 1999 and has been collecting data on X-ray sources ever since. Data from these and other observatories were also used, including optical data from Hubble and the European Southern Observatory's New Technology Telescope, TNT, additional infrared data from Spitzer, and additional X-ray data from European Space Agency's XMM Newton mission. These are represented in different colors, and each object is presented in individual wavelengths and as a composite data product. The combination of visible and non-visible light and side-by-side comparisons allow many fine details to be resolved. The full list of images can be found on the NASA Chandra mission website. NGC 346. The 4 renderings of NGC 346, posted above, show the cluster in terms of composite data: top left, infrared data; top right, X-ray data; lower left, and infrared, optical, and X-ray data, lower right. This star cluster is located in the SMC outside the Milky Way, roughly 210,000 light-years distant in the constellation Tucana. Different wavelengths are represented in purple, X-ray, red, green, and blue, optical, and red, orange, infrared. The Webb data reveals plumes and clouds of gas and dust, the material that will fuel the formation of new stars. These appear as a thick orange cloud running from the cluster's lower left to the upper right, with a similar patch found near the upper left. The Chandra data reveals the remains of a supernova from a massive star, the purple cloud on the left, and several young, hot, and massive stars, purple specks. Between the gas plumes, the cluster is densely packed with massive stars, white and blue, while a particularly young and massive star, the bright dot in the purple cloud, is shown blowing powerful winds outwards. Credit: NASA, ESA, STSCI, ESO, Optical, NASA, ESA, CSA, JPL, Caltech, STSCI, IR, NASA, CXC, SAO, ESA, XMM Newton, X-ray, Image Processing, L Frater, J Major, N Woke, and K. Arcand. A patch of smaller young stars and their powerful stellar winds can be seen in the center of the image, represented by small dots surrounded by a faint purple mist. NGC 1672 NGC 1672 is an example of a barred spiral galaxy, where the spiral arms extend from either side of a central bar-shaped structure. It is located about 5.7 million light-years away in the constellation Dorado. Chandra data also revealed compact objects like neutron stars and black holes, with a large purple cloud at the center indicating the presence of a supermassive black hole, SMBH. Other X-ray sources are peppered throughout the spiral arms, likely stellar remnants, dust clouds, and maybe some intermediate black holes. Optical data from Hubble reveals the cloudy nature of the arms, which are dotted by bright white and purple stars of varying sizes. It also reveals the large clouds of gas, dust, and the many stars surrounding the central bar. The Webb data helps resolve the densest concentrations of gas and dust in these arms and the large concentration around the center. The central region is bright and pinkish, surrounded by a murky silver cloud of material, indicating a diverse population of stars and lots of light absorption. M16, Eagle Nebula, Messier 16, also known as the Eagle Nebula, is a particularly famous object because of the iconic pictures of the pillars of creation, the tall columns of turbulent gas and dust that look remarkably like fingers reaching outward. This feature was imaged by Webb and Chandra alone, combining high-resolution data in the infrared and X-ray data. The Webb image shows the dark columns of gas and dust emerging from the bottom edge and stretching toward our upper right. These are backed by a dark orange mist, indicating clouds of diffuse gas and dust that shine in the mid-infrared. Credit: X-ray, Chandra, NASA, CXC, SAO, XMM, ESA, XMM Newton, IR, JWST, NASA, ESA, CSA, STSCI, Spitzer, NASA, JPL, Caltech, Optical, Hubble, NASA, ESA, STSCI, ESO, Image Processing, L. Frater, J Major, N Woke, and K. Arcand. The Chandra data reveals young, massive stars that recently formed, which appear as pink and purple dots because of their powerful X-ray emissions. In the combined image, these young stars look like fireflies flitting around the sky in front of a setting sun, the pillars appearing as billowing clouds. M74, Phantom Galaxy, Messier 74 is a spiral galaxy, similar to the Milky Way, located about 32 million light-years distant in the constellation Pisces. This galaxy is particularly interesting to astronomers because of its relative proximity and the fact that it is visible face-on to observatories on Earth, or in orbit around it. Messier 74 is also dimmer than other galaxies in the Messier catalog, making it harder to resolve with small telescopes. When viewed by powerful telescopes in the optical and non-visible wavelengths, the massively detailed and complex structure of the galaxy emerges. Hubble optical data already manages to highlight the galaxy's spiral arms, its bright core, the distribution of stars, purple, white, and orange, corresponding to their size and age, and the dust lanes and gas clouds throughout. Still, the Webb data outlines the gas and dust, which appear as silvery blue arms in infrared wavelengths. This reveals the swirling web-like structure within the spiral arms, while Chandra's X-ray data highlights the high-energy activity from particularly young and massive stars. Credit: X-ray. Chandra. NASA, CXC. SAO, XMM. ESA, XMM Newton. IR. JWST. NASA, ESA, CSA, STSCI. Spitzer. NASA, JPL, Caltech. Optical. Hubble. NASA, ESA, STSCI, ESO. Image processing. L. Frater, J. Major, N. Woke, and K. Arcand. These images are another reminder of the capabilities of the JWST, the most powerful and complex observatory ever sent to space. They also showcase the benefit of combining data from different observatories optimized to study the cosmos in different wavelengths. They're also symbolic in a way. For decades, NASA's great observatories combined data to reveal more about the universe. Combining Webb's advanced infrared imaging with data provided by these veteran observatories is like a passing of the torch. In the coming years, the JWST and other next-generation observatories, like the Nancy Grace Roman Space Telescope, will combine their respective abilities to discover more exoplanets, characterize their atmospheres, observe the earliest galaxies in the universe, and test the laws of physics in the most stringent ways. Further reading. Chandra Adblock Test. Why?